Well, there we go. All right, so now let's look at the power of Dan Osman. So let's do a quick review of where we were. We knew that the force that he was doing was m times g, which came out to be 65 times 9.8, which is the acceleration due to gravity that's overcoming 637 newtons. We came up with the distance that he went was 122 meters. All right, and we also, so now we need to know the work. So the work done is equal to the force times the distance. Notice the work is going up, the distance is going up, they're parallel to each other. So therefore, that's all we need. And we do 637 times 122, and that is 77,714 joules. Okay? 77,714 joules. I'm going to give you one little calculation that you might find interesting. All right, so how many calories did he burn? What are his calories? Because that's the energy that he needed, his body needed to make for him to get up there. Just like the gasoline in your car burns hot, and it gives you the energy to turn those engines, to turn the pistons so that they drive the wheels and all that kind of stuff. So how many calories? I'll tell you, I'll give you a little hint here. The 1 calorie, big C, is equal to 4,186 joules. Okay, well then that's not a big deal. Then so the calories that he burned climbing up there, this is a sidebar, would be 77,714 joules per 1 calorie, or per 4,186 joules per calorie. Now look what happens here. Because if I divide both sides by calories here, I wind up with 1 equals, I'm dividing by 1 here, because 1 is equal to 4,186 joules per calorie. Those of you that make your living with a slide rule understand exactly what I did. Some of you are probably giving me the, like when you play a high tone around a dog and they tilt their heads. So then the calories come up here. So basically you just divide. If you've got joules, you divide by 44,186 joules per calorie. And so if we divide by 4186, we wind up with 18 calories. That's it. Wow, I guess because it was in such a short amount of time. But the work is equal to the force times the distance. Yeah? Yep. So that's the big K. So there's only 18 calories. I thought it'd be a hell of a lot more than that. I probably missed something somewhere. That's what I get for just kind of winging it, just kind of winging. Yeah. All right. So this number of joules. Now, the time was, what did we say? The time? 265 seconds. So his power is equal to 77,714 divided by 265, and this will be in watts. Joules per second is equal to a watt. 293 watts. That's the wattage that he burned when he was going up there. All right? And we got the little thing here with the kilocalories too that he burned. 18 calories, that doesn't seem like much for all that work. I don't know about that. I guess, you know what? Because we got him going straight up, I mean, we're looking at the mechanical work. This is internal stuff. So I don't know if that might be the problem. But anyway, we'll keep it. If my boss watches it, if Dr. Kruger, I'm Pinky, he's the brain. If he watches this, he'll probably tell me, no, this you forgot about this. Oh yeah, I'm notorious for that. All right, out here.